All right. So, question 3. Just gonna get my notes for this first, and then okay. So, question 3: create two octic polynomial inequalities for which the solution to each one is x as an element of -4, union -1 to 3. Sketch a graph of each inequality to support your answer. So, some important things to note is first, octic just means a degree of 8, and uh, yeah. So, an important thing to note is that uh, these actually tell us the important x-intercepts we need for making our uh, making our function. So first, what you always want to write is x plus 4 bracket x plus 1 bracket x minus 3. Okay, that that's essentially the most crucial part um, for making your equation. So yeah, this is in factored form, meaning that the degree is equal to the sum of every exponent after a bracket. So for example, if there's an exponent 2, here, 2 plus 2 plus 2 is equal to 6. So this would be a degree 6 function. Likewise, to uh, 3, 2 plus 2 plus 3 is 5. Uh, sorry, yeah. So, no. Sorry, I'm a little bit stupid. So it's actually 7. So it would be a degree 7 function. Um, yeah. So the reason we are putting these points as our in our function is because you see here, these indicate that they're important uh, for our answer, and they're actually going to be x-intercepts in our equation, which is why these are in factored form are x-intercepts. Um, so yeah, I'm just going to tell you uh, what I did for the answer, and my answer was x plus 4 to the power of 2, x plus 1 to the power of 3, and x minus 3 to the power of 3. And as you can see, 2 plus 3 is 8, meaning it is octic. Um, so let's just graph this out. I'm going to create a graph here, or a Cartesian grid. Uh, plot our x-intercepts. So -4, -1, and 3. Yeah, and so uh, it's important to mention that the exponent after every bracket is actually really important for how the graph is going to look like. So right now, first we know it's an even degree positive function, so it's going to start off in quadrant 2, right? And since x plus 4 is to the power of 2, we're actually at the x-intercept, it's going to look like a parabola, right? But say, for example, it was actually just x plus 4 to the power of 3, right? Um, Instead of looking like a parabola, it would come down from quadrant 2, it would do that weird flex thing, and then it would go down into quadrant 3 rather than staying in quadrant 2. And it would also make x negative from plus 4 onward to our next x-intercept, maybe. So yeah, it's important to note that the uh, the order of the function really matters when plotting out this graph and plotting out when x is greater than or lesser than 0. So let's just plot this out right now. First, uh, we're going to come down from quadrant 2. We're going to do a parabola shape at the x-intercept. Then we're going to come down. We're going to do that weird flex thing that you get when you have an order of 3 function. And then we're going to come back up, do that weird flex. Sorry, I messed up there. We're gonna come up, do the parabola, do the weird flex, uh, weird flex again. I cannot draw it, but yeah. Essentially, these 2 points right here, they're at an order of 3, and the point right here is at an order of 2. So yeah, um, but this isn't the entire solution of the question, because we also need to determine whether x is greater than or lesser than 0. So uh, for this function, we're actually going to say that um, for this, x is, so between points uh, at point 4 or at point -4, and between points -1 and 3, we can see here that x is either equal to 0 or less than 0, right? And so because of that, we're going to say that it is lesser than or equal to 0, right? So the function is equal to 0 at -4, and the function is lesser than 0 at -1 to 3, which is why we did our function as lesser or equal to 0, right? But the question asks for 2 functions, and we're really just going to cheese this. X plus 4 squared times x plus 1 to the 3 times x minus 3 to the 3, and we're just gonna slap a negative sign as our a value here, and then we're also going to inverse the sign, so x is greater than, or the function is greater than or equal to 0. And what's that going to look like on our graph? Well, I'll plot it out really quickly because we've actually already, it's basically the same as our first graph here, except flipped upside down. So comes up from quadrant 3, makes a parabola shape at x minus 4, and then comes down, does the little order of 3 flex thing that I can't draw at -1, comes down, does the flex thing at y equals 3. And so, as we can see again, well, now x is equal to 0 at -4, and x is greater than 0 between points -1 and 3. So that's why we say our function is greater than 0, because this is when x is greater than 0, right? And yeah, that's how you solve question 3. I'd also like to mention that there are a lot of ways you can do this. So for example, instead of just doing negative and then everything again, you can do -1/2, you can do -2, you can do negative whatever you want. Um, there are also some other ways that you can do this. I recommend just like putting a bunch of random numbers that add up to 8 onto Desmos as your degrees. So I believe you can, I'm not entirely sure, but I believe you can do x plus 4 to the power of 4, and then x plus 1 to the power of 3, and then x minus 3 just on its own. And the degrees added up, it equals to 8, so it's an octic function. And I'm pretty sure that that it'll look really similar to this graph actually. But yeah, just plot in Desmos and you might get the same answer. I recommend like you look into it yourself, but there are a ton of ways to get the answer that wasn't mine, and yeah.